How's everyone doing? So today we'll do another video, and we're basically solving this question called subsets 2. And this is a pretty interesting question. There are a lot of ways to solve this question, and today we'll be discussing one of the ways that I found pretty useful and pretty interesting, and it will involve bits. So I know a lot of people get scared of bits, and I myself was pretty terrified of bits, but I think after the solution you will have a better understanding to solve questions using bits. Okay, all right. So let's say that for example our input is 1 2 2, right? That's our input. Now what if I say that consider a bit set with all zeros, right? That's a bit set of zeros. Now I ask you that what are different ways of placing 1 in this bit set. You may say that I place 1 in the first position, okay? I place 1 in the second position, or I can also place 1 in the third position, and so on and so forth. And this will be total number of such combinations will be 2 raised to power n, and n is 3 in this case, so total combinations will be 8, right? 2 raised to power 3, that is it. Okay, now the question is, how can we translate this concept, or how can we translate a problem to this bit set problem and solve it? Okay, so here's how we can do that. So what if I tell you that 0 in the 0 here in the bit set list correspond to the activation of 1 here? So let me clear it out. Let me write the input array here, okay, for each of the combinations, right? Now what if I tell you 0 here means that the corresponding element is there in the sublist or not? So 0 here means 2 is not in the sublist. 0 here means 2 is not in the sublist. 0 here means 1 is not in the sublist, so, or subset. So here is an empty subset because none of the input array is in the subset. Okay, let's take the next case. 1 here means 1 is in the subset. Okay, so 1 is a subset. 0 here means 2 is not in the subset. 0 here means 2 is not in the subset, so this subset just has 1 in it. Let's take the next. 0 here means 1 is not in the subset. 1 here means 2 is in the subset, right? And 0 here means 2 is not in the subset, so this subset will just contain 2, and so on and so forth. Interesting case, let's say when the last case of the combination, when everything is 1. Now every entry will get activated by 1, right? And it will contain the whole input array. If you have done some neural networks, it's basically when we multiply weights by the input layer, some of the input layer gets activated and some does not. So if you think this is an input layer to a neural network, these zeros and ones can be considered as weights, right? Or if you have done logistic regression, it's either 0 or 1, and we're basically activating that number. I just wanted to highlight how you can think about this problem. Okay, so that's how we can come up with all the subsets, right? And there will be total number of 2 raised to power 3, that is 8 subsets, and that's the whole theory behind this, right? Now I think the theory is should be clear. Now I will just paste the solution, right? Let me paste the solution here. Okay, we'll go to the solution one by one, but what I'm doing with the solution is, of course, I've coded it in C++, okay, and because that's my most comfortable language and my strongest language. So, but you guys can code it in any other language, and I will attach the code with the video. So here I have defined a superset variable that's basically total number of combinations possible, that is 2 raised to power num size. It will be 8 in this case. This is the vector that we are returning for the answer. We are also keeping a scene set, and because we don't want any duplicates in our answer, and are we also sorting the number. The sorting in number is important because we don't want to find any duplicates, right? And I will show you how that will help. So for the first for loop, okay, this is also important. So I told you all these combinations, right? Now how can we iterate through each of the combinations, right? The easiest way to iterate is to find its decimal equivalent. So 001 is equivalent to decimal 1, 010 is equivalent to decimal 2, and so on and so forth. Find its equivalent decimal number and do a for loop. So that's what I'm doing. I know that the last number in the combination will be 100. So that is that equivalent, that corresponds to 2 raised to power 3, right? And that is basically it. So that's what we are trying to do. And okay, all right, so let's do it. Now that's the for loop, right? And inside the for loop, what I'm doing is, for example, let's say currently I'm doing decimal 2, and that corresponds to 010, right? Now for each of this binary representation, right, or bit set, I'm checking if that value is activated or not, right? So that's what I'm doing from this line. I'm generating a mask. So for first I is equal to 0. So I is equal to 0, that means the mask will be something like this, okay? And this will be all zeros. Okay, this will be all zeros. And then I will check if this and this ands to 1. If this and this ands to 1, that means that this is activated, okay? And like this, I will check for each entry, right? I will check for, first I will check for this place, then I will check for this place. Here, when we AND 1 and 1, it will give us 1. And if that's what this doing, so if decimal and mask is 1, then I push back to temp. And I also keep a hash code, right, that I keep track here. So when this for loop goes like after every iteration of that for loop, I check if the hash code generated is already in the set, right? If it's not in the set, then I push back the temp into answer, and then I insert that hash code into scene set. Hash code is basically the string representation of the temp vector, right? So if let's say temp has let's say 1 2, right, 1 comma 2, that's the temp vector. Hash code will be 1 2, right? That will be hash code here. So that helps us with the unordered set, right? We don't have to do it something like that, but the benefit to do it like this is we don't have to write a custom hash, because string hash is already defined by default in C++. we can of course like calculate the hash code using something else. We can also use a vector for hash code, but then we would have to write a custom hasher for that, and it's just more lines of code. So I mean, it's at the end of the day, it's more of convenience and what everyone is comfortable with. uh, that's that. And we saw the number because for example, case like this, we have 2 1 and 1 2. Hash code for 2 1 will be 2 1, and hash code of 1 2 will be 1 2, but essentially 2 1 and 1 2 are the same number, right? I mean, the same subset. So but they have different hash values, as you can see. So for to solve that case, we sort all the numbers. So 1 2, after sorting will be 1 2, and after sorting will be 1 2, so that the hash code generated by them will be equal, right? And so that the unordered set, and then we can make use of the unordered set to avoid the duplicates. So I hope this problem should work. Let's decimal. Oh, my bad, I just changed that. Decimal. Okay, let's see if this problem works or not. So this problem should work, and yeah, so try it out. I mean, it's quite a different approach, I think, and I spent a lot of time thinking about it, and because it was a new concept to me too. So I guess it should be really fun to work with, and I hope you all guys have fun. As always, please like and subscribe this video. And sorry, subscribe my channel, not the video. Like the video, share the video if possible, and let me know in comments if you guys want me to make videos on core C++ language or any other language for that matter, or do you want me to make data structures and algorithm videos, theory videos, or practical videos like this, or anything else that you would like me to do in regards of software engineering, programming, artificial intelligence, and so forth. So thank you for watching this video, and see you next time.